us to another episode on ASUG 12 exams. So in this episode, we continue looking at the 2020 GCE Science Paper 1. So now we are looking at section B, where you're expected to answer all the 9 questions, and this section carries 45 marks out of 85 marks. So let us start with question B1. An object of mass 75 kg on Earth is taken to the moon, where the gravitational field strength is 1.6 Newton per kg. What is the mass of the object on the moon? So to answer this question, we need to bear in mind that the mass of an object is basically the amount of matter in a given object. So the amount of matter in a given object does not depend on the place, so it remains the same whether on Earth or on the moon. So basically in this case the answer is just 75 kg. B. Calculate the weight of the object on the moon. Now weight is given by a mass times gravity. So what's the mass? The mass should be in kg. So it's already in kg, which is 75 kg multiplied by gravitational field strength on the moon, which is 1.6 Newton per kg. So what you notice here, this kg and this kg cancels. You end up with basically 75 multiplied by 1.6. You get 120 Newton as the weight of this object on the moon. We move to question C. Give two differences between mass and weight. So basically what we notice here is, like we said on question A, mass measures the amount of matter in an object. That what mass measures. While on the other hand, basically while weight basically measures the force. So it's a force acting on an object. So we need to know the difference. So it's a force acting actually on the mass, of an object. That's what a force is. Then the other difference is the fact that a mass itself is a scalar quantity. It's a scalar quantity in the sense that a mass does not need direction, while a weight, is basically is a vector quantity. It's basically a vector quantity. So it needs a direction. Is it downward or upward? That's the difference between the two. So basically this is how you get the 5 marks on this question. Let us look at question B2. A bullet of mass 50 grams moving with an initial speed of 500 meters per second penetrates a hole and comes to rest in 0.2 seconds. Question A. Calculate the deceleration of the bullet over the 0.2 seconds. So what is important is always understanding the question. So the question is for us to calculate deceleration. Then we've been given the initial speed. Then also we know that this is coming to rest. So meaning the final speed is basically 0. So basically we are also given the time. So We know that acceleration is given by final velocity minus initial velocity over time, and this time you see the interval within that period we are calculating acceleration. So since deceleration is the opposite of acceleration, we can use the acceleration formula. So what is the final velocity? You see basically coming to rest, so it's 0 minus what's the initial velocity is 500 meters per second over time, which is 0.2 seconds. So this gives us minus 500 divided by 0.2, which gives us minus 2500 meters per second square as per case for acceleration. So because it's negative, we know that it's actually deceleration, which is the opposite of acceleration. So because it's deceleration, we are going to write it basically as a positive number, because the question is asking us to find the deceleration already. So we go to B, determine the retarding force acting on the bullet. So basically you see the force which is stopping the bullet. So we know that force is given by mass times acceleration. So we know what acceleration is, we've calculated it, and we've also been given the mass. Now this mass is in grams, it needs to be in kgs. So we know that in 1 kg we have 1000 grams. So basically to convert 50 grams to kg, we just divide by 1000, which basically gives us 0.05 kg. Then substituting, we have basically 0.05 kg multiplied by the acceleration, which is 2500. Then we end up with 125 newtons as the force acting in the opposite direction, or the retarding force. So basically this is how you answer this question to get the 4 marks. Let us look at question B3. Figure B3.1 below shows a pulley system. So we have effort and basically 120 Newton as the load. State the velocity ratio of the pulley shown in figure B3.1 above. That's question A. So when you're dealing with a pulley systems, basically velocity ratio is equal to the number of wheels in the pulley system. So we have 1, 2. So these two are the one that we need to count to give us the velocity ratio. So velocity ratio in this case is equal to 2. Remember, it's just the number of wheels in the pulley system. That's what is gives us a velocity ratio. B, if the efficiency of the pulley is 75%, what is its mechanical advantage? So basically efficiency, let me use a bigger space, efficiency equals basically mechanical advantage over velocity ratio multiplied by 100%. Then we are told that velocity ratio is 75%, so 75% equals mechanical advantage. Then we've already found the velocity ratio. Okay, we've already found velocity ratio in A, so we can substitute what with 2, then multiply by 100%. Then we can divide by 100% this side, and this side by 100%. So we have basically 0.75 equals mechanical advantage over velocity ratio. Remember, the question is asking us to find the mechanical advantage. Then at this point we can just do cross multiplication. Then we have basically 0.75 multiplied by 2, which is 1.5 equals 1 times mechanical advantage, which is mechanical advantage. So mechanical advantage is just 1.5. Let us move to question C. If the load is 120 newtons, what is the size of effort? So basically we found mechanical advantage. Then we know that mechanical advantage is given by the load over effort. So what have we been given? Remember, we've just found mechanical advantage to be 1.5. Then we've been given the load, which is, we shall call L, is equal to 120. Then the question is asking us to find the effort. So just substitute 1.5 equals basically 120 over effort. We shall just call it E. Then again we do cross multiplication to solve for E. So we have 1.5 effort E equals basically 120. We divide by 1.5, so we end up with E equals basically 80. So 80 Newton is basically the effort. 80 newtons. D. What work is done by the effort if the load is lifted 0.5 Newton? So basically the work done to what? Work done by effort if the load is lifted 0.5 meters. So work done is given by basically force multiplied by distance moved. So from here we know that the load is what? 120 Newton. Remember, work done by effort if the load, then multiplied by the distance, which is the vertical height, in this case is 0.5. Then we are going to end up with basically 60 joules as work done by the effort if the load is to move this load. So basically this is how you answer this question to get the 7 marks. Let us look at question B4. Waves travel at a speed of 30 meters per second through a medium. If 10 waves passes through a point per second, calculate the Roman numeral 1 frequency of the wave. So basically, what is frequency? So frequency is basically the number of complete waves generated per second. And from what we have been given, we know that so if 10 waves passes through a point per second, then we are asked to calculate frequency. So in this case, our frequency is just the number of waves passing through a point per second. So here we have 10. So this is basically will give us 10 waves, which is frequency, per the time. So the time here is per second, which is 1. So this becomes 10 A's. So 10 A's is basically the frequency. Then Roman numeral 2, wavelength of the wave. So basically we know that velocity is given by wavelength multiplied by frequency. So then we just divide by frequency to find wavelength. So wavelength is equal to basically velocity divided by frequency as a case. So what is velocity? So velocity in this case is equal to the speed, which is 30 meters per second. Then we divide by frequency, which is 10 A's. Then we divide. Then we end up with basically 3 meters. So 3 meters is basically the wavelength. So just pay particular attention, make sure that the speed is in meters per second, then the time is also in seconds. Otherwise, they need to be in the same units. Then B, what does loudness of a sound depend on? So basically, the loudness of sound depends on the amplitude of the wave. So it's basically amplitude of the wave. That's what determines the loudness of sound. So the larger the amplitude, the more the energy the wave has, and hence the louder the sound. So if the amplitude is smaller, what it implies is the sound will be lower. So basically, this is how you answer this question to get the 5 marks. Let us look at question B5. Figure B5.1 below shows a ray of light moving from one medium to another. So from medium A to B. Then question A, find the angle of refraction. So basically, the angle of refraction is basically the angle between refracted ray and the normal. So what is the normal? Basically, this is the normal. Then this is refracted ray. Then this is incident ray. So basically, to find the angle of refraction, we are looking for this angle. So we know that the entire angle, this angle is 90. So to find that angle, we just say basically 65 plus, let us say x, what we are looking for is equal to 90. So x is equal to basically 90 minus 65, which is basically equal to 25 degrees. So 25 is the answer. We go to question B. Calculate the refractive index of medium B. So basically, the formula for refractive index of the two media, in this case, so we're going to make an assumption that the refractive index of A is basically equal to 1, because otherwise we'll not be able to find it. So what we know is the refractive index of B over refractive index of A must equal to basically sine incident angle from basically A, then divided by sine reflected ray in after entering B. So what we are asked is to find a reflective index of B. So from the information, we know the incident ray is this, which is I. Then this is, we just found the angle of refraction. So basically, the only way we are able to find is to assume that the refractive index of A is a 1, such that when we place 1, then our equation becomes simple, because 1 into anything is that thing. So we have sine basically 50, so 50 degrees, as you will see from here. This is 50, then divide by the reflective angle of refraction, which is sine 25. Once we do that, basically simplify, we're going to end up with 1.8126, which when written to one significant one decimal place becomes 1.8. Let us write to 2 decimal places, 1.81 as the refractive index. Then see which of the two media is denser than the other. So basically what happens is this, if you have this is the normal. So if basically we have this ray enters here, if this is A, then this is B. If the light bends towards normal, what it means is B is denser than A. If this ray of light bends away from the normal, as you see in the red ink, then it means A is denser than B. So in this case, as you see from the figure is bending towards the normal, so meaning B is denser than A. So basically that's what you need to know. So medium B is denser than A. So basically this is how you answer this question to get the 4 marks. Let us look at question B6. Figure B6.1 shows an object O placed in front of a thin converging lens of focal point F. So basically we know that we are dealing with a converging lens. Question A, complete the ray diagram to locate the position of the image formed by the converging lens. So basically what we need to know is understand where the object is. So if the object is at F, then we need to know where the image will be formed. So in this case the object is at 2F. So ideally if the object is at 2F, the image will also be at 2F on the other side of the lens. So to complete the ray diagram, we need to draw a line parallel to the principal axis from the top of the image going into the converging lens. So we draw a line like this. It is this one, and this is a straight line. Then once it reaches the converging lens, it will bend to pass through the focal point, this F. So it will bend and pass through the focal point like that. Then we draw another ray of light that will pass through the optical center. Then where the two meets, that's where the image will be formed. So we use a ruler and draw a straight line using a ruler like that. What we discover is these will meet somewhere here. Then the image will be formed at this point like that. So basically this is how you complete the ray diagram, and just make sure that you light this one as the image, you label it properly. So basically once you do that, you are good to go. Then you also indicate the direction, this and that. Make sure that the direction of the ray of light is indicated. So basically you get the 2 marks. Now just you need to know that basically these are the key things that you need to know. If the object is basically between F and which is between F and 2F, if that's where the image, the object is, basically you know that the image, okay, the image will be formed beyond this point. So it will be formed in this direction to the right of 2F, okay, the right of 2F. So you need to know that, ensure that that's understandable. Then if the object is on this side, which is beyond 2F, the image will be formed basically in this region. It will be formed in this region. So you need to understand that it will be formed between 2F, the focal point, and 2F. Then lastly, if the object is basically between the optical center and F, the optical center and F, then what you notice here is, in this case, basically we are talking about, let me use a different color here. If it's in this region, the image will be formed on the same side, which is this region, as long as the object is in this region, somewhere here on top, this region. So it will be basically on the same side as the object. and that image will be basically virtual. So I wanted that to be clear. Let us look at B. State the characteristics of the image formed. So B, so the first characteristics of the image formed is the fact that the image is real. Number two, quickly, is that the image is basically inverted in the sense that it's upside down. Number three, because the object is a 2f, like I have already talked about that, because the object is a 2f, the image is formed at 2f. So because image is also formed at 2f, this implies that image is the same size as the object. So these are the key characteristics of the image formed. So in terms of in case we came across a question that would ask you about the application, so this is the case where you are using a photocopying machine. You input a A4 paper to photocopy a paper, then to also give you A4 paper of the same quality, the same size. So this is where this application works. We move to C, calculate the magnification of the lens. So basically magnification, if we are asked to calculate magnification, then magnification M is given by the height, so height of the image, then divide by height of the object. Then that's the magnification. So we need to know, or alternatively you could use basically a distance of image from C, which is the optical center, then a distance of object from C, the optical center. So we can go with either of the two, but we know that the image is formed at 2f and the object is also at 2f. So the distance from optical center, these distances are the same. So this, what it tells us, is basically equals to 1, regardless of the number of units, 1 over 1. Or if you want, you could count, you could assume that this is basically 1 centimeter. So this will be this is 2 centimeter, and this is, so this will be 4 centimeter, and this side it will be 4 centimeter. So we end up with just basically 4 centimeter over 4 centimeter. We end up with 1.0, which is 1. So magnification in this case is just basically a 1, which is 1.0. Similarly, you could have used the height. So you could have come here and look at this height. So this height is about 1 centimeter. If you assume this box is 2 centimeter, and this height will also be 1 centimeter, so it will just be 1 divided by 1 over 1, which is still 1.0. So basically this is how you find the magnification. So basically this is how you get the 5 marks on this question. Let us look at question B7. A step-up transformer increases the voltage of an AC supply from 110 volts to 220 volts. The primary coil dissipates a power of 1.1 kilowatt and the transformer has an efficiency of 100%. If the number of turns in the primary coil is 400, how many turns are in the secondary coil? So in this case, we are being asked to find the number of turns in the secondary coil. So what have we been given? So we've been given the voltage in the primary coil, then the voltage in the secondary coil, then the number of turns in the primary coil, then the power in the primary coil. Then we also told that the transformer is 100% efficient. So to find the number of turns in the secondary coil, we use this fact that the number of turns in the secondary coil divided by the number of turns in the primary coil is equal to a voltage in the secondary coil divided by voltage in the primary coil, which is basically means that we need to substitute there. So we know that the number of turns in the secondary coil is what we are being asked to find. So this is basically x equals then what's the number of turns in the primary is basically 400. What is the voltage in the secondary is 220. Then over what's the voltage in the primary is 110. As you see from here, then we solve for x. So because I can just make x the subject to the formula by doing 220 multiplied by 400. So I'm multiplying 400 both sides so that this one cancels. Then equal over 110. So basically what has happened is I've just multiplied by 400 this side and 400 this side, so that this and that cancels. You get? Yeah. Then that's what has just happened. Then from here we know that 110 into 110 is a 1, 110 into 220 is a 2. 2 times 400, we end up with x is equal to 800. So this 800 is a number of turns. So we have 800 turns in the secondary coil, which makes sense because this is a step-up transformer. Then how much current flows in the primary coil? So to find the current flowing through the primary coil, we need to extend this. Remember, there's this extension. So now it's basically current in the primary coil over current in the secondary. So I've used the lead so that you pay particular attention. What you notice here is the number of turns and the voltage are all in this case on top, but here the current is down. It's the opposite. Okay, so make sure that you know this. So once you know this, you can answer any question on a transformer. So let us use, so you can just pick two of this. So let us pick the voltages and the current. So basically we need to know the current. So the first thing that we can do is we can find the current in the primary coil. So you can find the current in the primary coil using the power that we've been given. We know that basically power is equal to current times voltage. So we've been given the voltage in the primary and the power. So the power is 1.1 kilowatt, which is 1100 watts, is equal to a current multiplied by a voltage, which is 110. Then we solve for I. So I basically equals to, by dividing 110 and 110 this side, that and that, then we end up with a current which is I. So current is equal to basically 10 amps. So if you know current in the primary coil, we can easily find current in the secondary coil. So in the primary coil, we know what it is. It is basically 110 amps. So now, like I said, using this that we need to know, we can find the current in the secondary coil. So we just use that. We know voltage in the secondary coil is 220 over voltage in the primary, which is 110, is equal to, then current in the primary is 10 amps divided by, we are looking for current in the secondary, which is X. So we just choose this formula. Then we just do a cross multiply. So by now doing, because X is done, cross multiplication, this tells us we have basically 220x is equal to basically 10 times 110. We have 1100, like that. Then we divide by 220 to find x. So that and that. So what we know is 11 into 11 is basically 1. So on top we have a 10. 11 into 22 is a 2. 2 into 10 is basically 5. So we have 5 amps as equal to x. So x, so the current in the secondary coil is basically 5 amps. So remember, this formula is very, very important. So basically, this is how you answer question B7 to get the 6 marks. So let us look at question B8. Figure B8.1 below shows two pairs of 3.0 ohms resistors connected to a 6 volts battery. Calculate resistance in the circuit between M and N. So basically what we know is we have two lines. So the top basically is a series. Up to here, this is in the series and this is the series. But if you compare these two, we have again the parallel. So the first thing that is, we need to find resistance on the top line, which we shall call RT, is equal to basically, because these two are in the series, we just add the 2. So it will just be basically 3 plus 3, which gives us basically 6 ohms. Then a resistor at the bottom, which we shall call B, will be equal to basically again 3 plus 3 equals 6 ohms. So you see, when you treat these two, the bottom and the top separate as basically series. So we have the combined in those two lines. Then from there, we need to find now the resistor of these two combined, the top and the bottom as in the parallel. That's what we need to do. So now the combined resistor will equal to basically RT multiplied by RB over RT plus RB, which was equal to basically 6 times 6 over 6 plus 6, which will be equal to 36 divided by 12, which will end up with 3 ohms. So 3 ohms is basically the resistance in the circuit between M and N. Then we look at B, current through the battery. So current through the battery. So in this case, to find current is given by basically voltage over resistor. Remember from the fact that a voltage is equal to basically the multiplication of a current and the resistance. So we have the voltage is basically 6 volts. We divide by the combined resistor, which is 3. We end up with 2.0 amps. So 2.0 amps is basically the current through the battery. Then we can go to the other part, which is section C, the power developed in the battery. So the power is given by basically a voltage times current. So we've already found a voltage you are given, which is basically 6 volts. Then we found a current to be basically 2 amps. So you have to make sure to find the current correct. If you mess up on the current, then you mess up everything, multiply by 2. So we're going to end up with basically 12 watts, okay, as our answer. So basically this is how you get the 6 marks on this question. Let us look at question B9, which is the last question from section B. Radioactive iodine is used to treat tumors of the thyroid gland. It decays by emitting beta particles and gamma radiation. The beta emitting process is represented by the following equation. What is the nucleon number of the new nucleus Z formed? So basically we are being required to find the nucleon number. So the first thing that we can do is to represent this decay equation. So we have 131 iodine, then with nucleon number 131, then we have proton number which is 53. Then this one will decay by emitting this a beta particle. So now what will happen to the new element formed Z? So basically when it undergoes a beta decay, so it will emit 1 electron, which is this negative. So because this 1 electron is emitted, basically what will happen is the atomic number will increase by 1. Okay, so the atomic number, which is this one, will increase by 1, so we are going to have 54. But what will happen to the nucleon number is the nucleon number will remain the same, because once this electron has been emitted, what will happen is 1 neutron will change to a proton. So hence the nucleon number remains unchanged. So what is changing is because once it emits this an electron, what happens is we need another proton so that the charge is balanced. So one a neutron, which is neutral, will become a positive. Hence you are seeing no change in the nucleon number. So basically the nucleon number remains 131. So this is basically what is happening. Question B, the half-life of iodine 131 is 80 days. The total dose of iodine given to a patient initially emits 4 multiplied by 10 to the power 8 rays per second. How many gamma rays does the total dose of iodine emit each second after 24 days? So we have the half-life, then we have the period, then we have the counts per second, the rays. So basically we can use the famous half-life equation, which is basically given by half-life is given by so what is the variable amount is equal to initial quantity, then multiplied by half to the power the time that has passed over the half-life. So we are looking for A, then we know what this is. So this is basically 4 multiplied by 10 to the power 8, which is the same as 400 then million. So it's better to million, because remember the power 8, it means we have 80 zeros like this. So these are million. Then we know time is 24, then half-life is 8 days. So just substituting then to find M, we have basically, I will rather write this as in million, which is 400 million. I know it's in million. Then multiply by half, then 400 million. So which I can write here to make it easier for my examiner, 400 million. Then we have time is 24, then over half-life is 80 days. So we have basically 400 multiplied by half to the power 3. Remember, half to the power 3, because 8 into 24 is 3. So we are going to end up with basically 400 million multiplied by 1, because 2 times 2 times 2 is 1/8. Then 8 into 400 is basically 50. So this is 50 million, which is the same as basically 5 multiplied by 10 to the power 7. 5 multiplied by 10 to the power 7. Remember, because this is 6 powers, then when we move how many decimal places? We are moving from here 1, 2, 3, 4, 5, 6, 7, so that we write it to the way it was written. So basically that's the answer. So we have 50 million, 5 multiplied by 10 to the power 7. So basically this is how you answer this question to get these quick 3 marks. This is where we end with section B. Please join me on section C as we look at each question critically.